Today we're going to take a look at 8.2, multiplying and dividing rational expressions. A rational expression is just a quotient of two polynomials. That just means that you're going to be dividing them. Because rational expressions are ratios, meaning they look like fractions, you can simplify them the same way that you simplify fractions. When we talk about being able to simplify fractions, really what we're doing is we're taking a look at the two numbers that are within that fraction, and we break each one of those numbers down into smaller factors. And when we say factors, what we mean is that we're multiplying these numbers together to be able to create that bigger number. And when we break them down into the smaller numbers, if they have common factors, like the 9 and 24 have a 3 in common, you can cut that 3 out of the problem. You can cancel it out, which leaves us with 3 over 8. We can do that same exact thing when we talk about being able to simplify rational expressions, except we're just going to be dealing with polynomials instead of just numbers. So here's our first example that we're going to take a look at, is being able to simplify these. The first thing we want to do is being able to talk about breaking it down into factors. Well, right now we really just have a monomial over a monomial, so we just have to take a look at the individual pieces itself and say, is there anything that we can simplify? If we start off with the numbers, the 3 and the 2, those two things can't be reduced, so we're just going to leave it as 3 over 2. The x to the 7th, though, and x to the 4th, those two can be reduced. The x to the 7th is basically just saying that you have 7 x's. That's what x to the 7th means, divided by x to the 4th, which would mean that you'd have 4 x's. Well, if you have 7 x's over 4 x's, you can go through and start canceling out your x's, leaving you with really just 3 x's on the top. So we can go back to this fraction and we can put in 3 x's up top, or x to the 3rd. That's our simplified rational expression. The second part to this question, though, is saying identify any x values for which the expression is undefined. What that means is really we're dealing with a fraction. Are there any numbers that we can put in for x that would make this fraction undefined, as in basically make this a fraction that we can't actually find a value to? And the only thing that we're not allowed to see in a fraction, any kind of fraction, is a 0 in the denominator. So really what this question is asking us for is there any number that we can put in here for the x to be able to create a 0 in the denominator? And we have one value to be able to put in there, and that value would be 0. So what we're saying is x cannot be equal to 0, because that would give us an undefined value. Basically, if we plugged in 0 for both of these, we would get 0 over 0. And we don't really care so much about the 0 up top, that's fine, but it's that 0 in the denominator that's going to cause us issues. So we say x cannot be equal to 0, it can be any other number, that would be fine. If we take a look at example B now actually throws in bigger polynomials. Here we have a trinomial over a trinomial. The first thing that you might want to say is, I see an x squared over an x squared, so I may want to cancel those out. The problem is we can't actually cancel those out. That x squared isn't a factor. That x squared is part of a factor. The factor itself, the big polynomial, is x squared minus 2x minus 3. And here we have x squared plus 5x plus 4. This is one whole factor within itself. It's one trinomial. Think if we go back to this one, it was 3 times 3 over 8 times 3 that we could cancel out the 3's. Well, if we saw something like 3 plus 3 over 8 plus 3, could we cancel out the 3's in this case? No, we can't cancel out the 3's here, so we're not going to be able to cancel out those x squareds. What we're going to need to see to be able to cancel something out is we're going to need to see things contained within multiplication. And right now that x squared is contained within that minus 2x and that minus 3 through addition and subtraction. So to be able to create factors like what we saw up here for this polynomial down here, is we just need to go through and we need to factor it. So we take a look at x squared minus 2x minus 3 and say, how do we factor this? It's a quadratic trinomial, so we can create two sets of parentheses, put in our x's here. First thing we want to do is figure out what our signs would be. If we take a look at this last number, it's a -3. You're trying to come up with two numbers that multiply to give you -3, which if you have two numbers that multiply to give you a negative, that means one of those numbers has to be a positive, one of those numbers has to be a negative. That's the only way to multiply two numbers to get a negative. And then we can take a look at the 3 itself and say, what numbers can we actually use for the 3 that multiply to give us 3? Our only option that we have is 3 and 1. Well, those two numbers that multiply to give us a 3 also have to add to be able to get us that -2. Well, it's trying to get a negative here. We know that it's got to be this combination if we're going to factor it, and we know that A negative 3 and a positive 1 will give us a negative 2, so we can put in a negative 3 and a positive 1. If you're not sure, if you know that the 3 and the 1 can combine in a way to be able to get you that 2, if you see the negative sign here, that's going to tell you that the bigger number is going to have to carry that sign to be able to keep that sign when you put two different signs together. And we could do the same thing down here. We take a look at the end operation there, which is a plus sign. That's going to tell us that our two signs need to be the same. It could be a negative negative to create a positive, as in a negative times a negative. It could be a positive times a positive to be able to create a positive. But if we look at this sign here, two negatives do not add to get a positive, but two positives do. So it can't be in the negatives. It's got to be plus plus. And then we look at the 4 and say two numbers that multiply give us a 4. This could be a 4 and a 1. This could be a 2 and a 2. Well, only one of these combinations will add to get us a 5. It's got to be the 4 and the 1, so we put in the 4 and the 1. Once we factored, if we take a look, we really just have a binomial here multiplied with a binomial here. Same thing on the bottom, which if we take a look, we see that there are two of the same binomials, one up top, one on the bottom, and we can cancel out the entire binomial because it's just this one thing multiplied with this other thing. It's almost like we're canceling out the 3 and the 3 up here. Instead of trying to just cancel out part of the trinomial, we're actually canceling out the entire binomial, leaving us with just x minus 3 over x plus 4. There's our simplified rational expression. Now, to answer the second part about where that expression is undefined, what we need to do is go back to the original problem with the x squared plus 5x plus 4 and say what's going to make that denominator equal to 0. Well, to be able to solve a quadratic when it's set equal to 0, you need to go through and factor it, which we already really did factor this, so we can set this bottom one equal to 0, x plus 4 times x plus 1 equals 0. The way that we solve a quadratic that's already factored, that we have these two things set equal to 0, is we just need to set each one equal to 0 itself. And when we set them both equal to 0 and solve them, we get x equals negative 4 and x equals negative 1. Those are the two values that will make the denominator equal to 0, so those are really the two values that we do not want this to be equal to. So we're saying to make this an undefined expression, x would have to equal negative 4, x would equal negative 1, so we're saying now we don't want x to be those two numbers. If we take a look at this third one, 2x minus x squared over x squared minus x minus 2. Do the same exact thing. We want to be able to factor it. So we take a look at the top and we see that they have an x in common. We can take out an x, leaving us with 2 minus x. And in the bottom, same exact thing. Factor, it's a trinomial, so we can make the two sets of parentheses. Numbers that would multiply to give us a negative 2, well, we know that's got to be a positive and a negative. The only option that we have for 2 is 2 times 1. To be able to get the negative 1, those will work. We just have to have the negative 2 and the positive 1. Well, if we look at this, we can see that this 2 minus x and x minus 2, they're not the same, but they're close. One has a positive 2, the other one has a negative. First one has a negative x, this one has a positive. They're opposites of each other. Well, we can work with the opposites of each other by just taking out an extra negative sign. So we're actually going to factor out another negative sign out to put in front of that x, which when we take out a negative, that's going to make our positive 2 a negative 2, and it's going to make the negative x a positive x, which negative 2 plus x is really the exact same thing as just being able to say x minus 2, which when we have that over the x plus 1 times x minus 2, there's the x minus 2 to go with that x minus 2, so those two things will cancel out, leaving us with just negative x over x plus 1. And that's our simplified rational expression. The second part of this, checking to say where is it undefined, is just set that denominator equal to 0 before we actually went through and simplified it. Is if we set that thing equal to 0, it's just setting each part equal to 0. So x plus 1 equals 0, x minus 2 equals 0, which would tell us x would equal negative 1, x would equal 2, which means those would be the undefined values. So x cannot equal those two numbers.